Hi everyone, let's discuss programmable DMA controller. Then what is DMA? Direct Memory Access. DMA is an operation in which data is copied from one resources to another resources in a computer system without the involvement of CPU. Then the task of a DMA controller is to copy the data to be performed from IO devices to memory, memory to IO device, memory to memory, IO devices to IO device. The bulk data transfer from IO devices to memory or from memory to IO devices through the accumulator is a time-consuming process. For such a situation, the direct memory access technique is preferred. Then, direct memory access controller is independent resources of a computer system added for the concurrent execution of the DMA operator. Then, the DMA controller replaces the CPU for the transfer task of data from IO devices to main memory or vice versa, which otherwise could be executed by CPU using programmed input-output mode. The CPU initiates the transfer, does other operation while transfer is in progress and receive an interrupt from DMA controller when the operation is done. Then let's discuss the Intel A257. Intel A257 is a programmable DMA controller. It is a 4-channel programmable direct memory access controller. It is a 4-pin IC package and require a plus 5 volt supply for this operation. 4 IO devices can be interfaced to the microprocessor through this device. Okay, then let's discuss the pins of the Intel A257. D0 to D7, these are the data lines. These are bidirectional 3 states lines. Then CS bar is the chip selector. Then clock reset. Then A0 to A3 are bidirectional line address lines. Then A0 to A7 are the address lines. A4 to A7 are address lines. Then input output read, it is bidirectional in which output mode is used to access the data from input devices during the DMA write cycles. Then input write output write, it is a bidirectional line. In output mode it allows the transfer of data input output devices during the DMA read cycles. Then ready, HRQ is the hold request, HLDA is the hold acknowledgement. Then MEMR is a memory read, MEMW bar is the memory write. Then DRQ. DRQ0 is the DMA request lines. Then DRQ0 to Q3 are there. Then an IO device send its DMA requests of one of these lines and a high status of the line generated DMA request. Then DACK0 to DACK3, these are the DMA acknowledgement lines. The Intel A257 send an acknowledge signal through one of these lines informing IO devices that it has been selected for a DMA data transfer. Then AEN is the address latch enabled. Then ADSTB is high on the line latches of 8 MSB of the address which were sent on dbus into Intel A21 to connect for this purpose. Then TC. Then TC is the terminal counter. Mark is the modulo 128 mark. Then the A257 offer 3 different modes of operation: DMA read, DMA write, DMA verify. In DMA read, which causes data to be transferred from memory to peripheral devices. Then DMA write, which causes data to be transferred from peripheral to memory. Then the DMA verify, which does not actually involve the data transfer. In the DMA verify mode, it will respond the same as described for transfer operation, except that no memory or input output read write control signal will be generated, thus prevented the transfer of the data. Then execution of the DMA operations. Initially, when any device has to send data between the device and memory, the device has to send a DMA request to the DMA controller. That is, the DMA to send a DMA request for the DMA controller. Then the DMA controller send the hold request to CPU on hold lines and wait for the CPU to assert the HLDA. Then the microprocessor tri-states all the data bus, address bus and control bus. The CPU leave over the control bus and acknowledge the hold request or HLDA signal. Now the CPU is in hold state. Then DMA controller get the control of the bus. It is send the memory address. Then it also send the DMA acknowledgement for the acknowledgement, that is the DACK signal to the disk control devices. Finally, it asserts both the IOR and the MEMW signals on the control bus. Asserting an IOR signal enables the disk control to the output, the data from the disk on the data bus, and MEMW signal enables the address memory to assert the data from the data bus. In this technique, data is directly transferred from disk controller to memory location without passing through the CPU or DMA controller. It has provided another control signal marked to indicate peripheral that the current DMA cycle is 128 cycle since the previous mark output. It has a priority logic that resolves the peripheral request. The priority logic can be programmed to work in 2 modes, either in a fixed mode or rotated in priority mode. It allows data transfer in 2 modes, burst mode and cycle steal techniques. It can execute 3 DMA cycles: DMA read, DMA write and DMA verify. It operates in 2 modes, slave and master. In master mode, it gains the control over the system bus. In slave mode, buses are under the control of the processors. Okay, thank you.